Alright, welcome back. This is part 2 of the previous video for probability for combined events, also known as joint events. So, we figured out the probability of both things happening, and we're going to actually use that skill for the second half. So, for this piece, we need to find the probability of either event happening. So, if one of the events, or both of them happens, we still consider it a success. Now, let's think about this for a minute. We flip a coin, and we want to land on heads, or we have to roll a 5 on a die. Is this more difficult or less difficult than winning one of those separately? Well, let's take a look. Let's think it out. Alright, let's use a coin. Landing on heads again. We like to use the landing on heads. People enjoy that. So, 1/2 probability, so 50% of the time we win. We just went over that before. It seems just as easy to win than to lose. We should expect to get heads about half the time, and out of 100 trials, we should get around 50 wins and 50 losses. Alright, let's look at our second piece, rolling a die and landing on a 5. It's a 6-sided die. It's a 1 out of 6 probability. It's about 17% of the time we will win. A little bit more difficult to win than the coin. And we should expect to win once out of every 6 games. Once again, remember, this is not guaranteed. Every 6 times you roll the dice, you're only going to win once. You could win 1 time, 2 times, 3 times, 4 times, 5 times. You could win 6 times, which is really, really crazy odds of happening. Or you could also win 0 times. So these are things that we need to keep in mind, that theoretical does not guarantee that things are going to happen. Out of our 6 tries, we should probably expect to get around 1 win and 5 losses. Once again, those numbers can change. Alright, what about winning either of them? Let's take a look. So the coin is 50%, and the 5 on a die is roughly 17%. Let's calculate those odds and take a look. Alright, we're going to build a table. Alright, this table is going to show every single possible outcome. We have the coin flip, then we have a comma, and then we have the number that we could roll on a die after. So for example, right here, heads and rolling a 1 on a die, heads 2 on a die, heads 3 on a die, 4, 5, 6, and then we have tails with 1, 2, 3, 4, 5, and 6 as well. So what we need to do is we're just going to color code them so we can see what they look like, and we're going to see which ones are our possible table of winning outcomes. Alright, let's take a look at this. We have heads every single instance, so all 6 of the items on the left. And we also have that tails with the 5, because 5 is also one of our winning pieces. Now here's the interesting thing. We have one occurrence where it's technically a quote-unquote double win. We still win if both happen. So heads comma 5, this item right here, is both conditions being satisfied. We're going to look at that a little bit later, and that's going to play a role in figuring out our equation. But in this situation, we can count 7 ways to win and 5 ways to lose out of our 12 possible outcomes. There's no other possible outcome I can think of. It's just heads or tails, and then it's 1 through 6. We have every single combination done out because we did it nice and organized. All right. So how could this relate to our 2 statistics, 1/2 and 1/6? Well, let's take an analyzing approach and look at the following. When finding the combined probabilities of an event A or B, we must use the following equation. The probability of A or B, right here, is equal to the probability of A plus the probability of B, and then we're going to subtract the probability of both A and B happening at the same time. So we need to keep this in mind because that's an important piece at the end of it. And the P of A and B, we're going to realize that's that double win that I was talking about, because both items occurred when we only needed 1. And in a statistics or a probability sort of way, having the double win kind of skews the results if you don't look at it the right way. So we're going to take a look at this the correct way. Alright, so the odds of either event. The P of A or B is equal to the P of A plus the P of B. Subtract the P of A and B together. Alright, so this is a little bit sloppy, so I'm going to highlight things as I talk about them. A equals the heads on the coin, that's our first event, and event B is rolling the 5 on the die. Alright, probability of A is 1/2, we know that, that's the coin, and the probability of B is 1/6, which is the dice, or the die. Alright, so our equation says the probability of A or B is equal to 1/2 plus 1/6 minus 1/12. I'm going to actually go back a couple slides, and we're going to look at that logic chart again, and we can see exactly where it comes out as 1/12. So I'm going to go up, up. Here's our chart. So we have these 6 heads over here. And we notice this one of them is the double win. Heads and 5 translates to both situations being satisfied. So that's the probability of A and B. There's only one time that it can occur. And if we count the number of boxes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where we got the 1/12. What you could have also done is gone back to our equation. I'm just going to scroll up really quick all the way up to the top. Let's see, where's that equation? It is right here. The probability of A and B, we learned before, is the probability of A times the probability of B. Let's scroll back down to our problem, and we can look at that. It's 1/2 that we got from here times 1/6. If you multiply the 1's across, you get 1. If you multiply the 2 and the 6 together, you get 12. So there's our 1/12, and I just showed you 2 different ways to get to it. Use whichever one you think is best for you. However, if you get to something large, like a deck of cards, I don't think you want to sit out there and write out every single possible card that could show up. Especially, let's say, if you're rolling a 20-sided die or picking a marble out of a bag of 100. I don't think we'd have enough time to seriously go through and analyze every possible situation. So, alright, that's our equation. You just plug them in. Sometimes you might have to do a little bit of math. Sometimes you have to combine your fractions together. And actually, I didn't even put down the solution down here. So, the probability of A or B is equal to, I'm just going to center it, alright, 1/2 plus 1/6. So that translates to, if we look on our common denominator, we're going to reduce to 8 out of 12. It also reduces to 4 out of 6, but I'm going to bump it up to 8 out of 12. You just simple multiplication. Check the previous videos. I'll link them at the bottom if you need them. Because we want to get that 12 denominator over here as well. So that's minus 1 out of 12. Alright, and when we do our final math, P of A or B is equal to 7 out of 12. Well, if we look at that result, 7 out of 12, that actually directly translates to here. 7 wins out of 12 outcomes. So those numbers matched up. It worked out good. We can kind of see the logic that's going on. We got a new couple formulas we need to play with, but I think we should be feeling pretty confident at this point. If you watch this video again and again, if you're having difficulty, you can definitely learn each of the equations. Alright, so, once again, excuse me for that. Alright, we're going to try it on our own. I would like you guys to pause the video again, when I'm done talking of course, and try the following problems. Let's take a look at this first issue, or the first problem, flipping 2 coins and either one lands on heads. So you can plug it into the equation, or you can use some logic and build a chart. If you want to see the connection between them, I suggest trying both. And the second one that we have is rolling a 10-sided die and landing on a 1, so that's a 1 out of 10 chance, and also flipping a coin and landing on heads. And the thing I'd like to keep in mind is to please remember, the probability of A or B, so these are the 2 equations we're working with, is the probability of A plus the probability of B minus the probability of A and B. Now, the probability of A and B, we have that equation before, so if you get stuck doing that, all you need to do is rewind the video back and you'll be able to get what you need. Alright, so pause the video now. You can resume when you are finished and you want to check your work. Alright, so we're going to switch to the answers. Alright, so in this case, 2 coins both have a probability of 1/2. So it's 1/2 plus 1/2, because those are the probabilities of A and B. Then we subtract the probabilities of both. So they're both we look at this, and we have 1/2 plus 1/2 minus the 1/4, because it's 1/2 times 1/2. And that gives us 3/4 as our probability. And we should expect, every 4 times we flip in the coin, probably what will happen is we're going to get a heads 3 out of every 4 times. At least 1 heads. We can get both, or we can get 1 from either of the coins. Alright, Our second one, we have a 10-sided die, 1 out of 10 probability. Our coin is 1/2 probability, so it's 1 out of 10 plus 1/2 minus the probability of both of them, so we just multiply, it's 1 out of 20. Alright, we plug it in, we find common denominators. It looks like 20 is that magic number, so 1 out of 10 turns into like 2 out of 20, plus 1/2 turns into 10 out of 20, and then we subtract 1 out of 20, so that's 2 plus 10 gives us 12, and yeah, we subtract the 1 out of 20, it brings us down to 11 out of 20 times. Alright, so let's get a quick review on this so we can look at, and then we can kind of call it a day. Alright, so in our review, the joint events using the phrase AND is just the probability of A times the probability of B. So for example, we did 1/2 times 1 out of 52. That's a coin and a deck of cards. We simply just multiply them. It's pretty easy. It's across the top, across the bottom. We figure it out. If we can reduce it, awesome, we do it. If not, we just kind of leave it as it is. And the next thing, we have joint events, the OR events. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both the events happening at the same time. So you add the odds, or the probabilities of it, and then you subtract the probability of both items happening. Alright, so if you have questions, please feel free to write them down and bring them in tomorrow so we can take a look at it. If you're having difficulty, please make sure you watch the video at least one more time. Go through each of it, make sure everything seems to be flowing smooth. If you still have questions then, bring them in, we will take a look at them. Alright, so I would also like to leave you with a little bit of food for thought. If it came to you smoothly for this, think this one out, try it out. Alright, here's our food for thought. What if we wanted to calculate the probabilities of 3 events happening, either with the AND or the OR combinations? So let's say we want to flip 3 coins, and now we're playing with the idea of what if any of them lands on heads? What are those odds? What about 4 events, or 5 events, or 200 events? Maybe there could be situations that could allow us to perform these calculations. And another question is, what if we wanted to find the probabilities of something that's ridiculously complex, like probability of A and B, or C, and D, and E, or F? And the other thing is, what if it's A and B together, but then the or C and D and E or F are all part of their own group as well? Or what if A and B or C are part of a huge piece? So now we're starting to look into PEMDAS and order of operations when we're playing around with these ideas. It's going to get complicated, but we're going to tackle it. Alright, this has been Mr. Fadouk. It's been a pleasure teaching you for today. Make sure you finish the homework, try it out. Be sure to bring in your questions. We're going to be trying some seriously cool probability work tomorrow. Have a great night.